ANSYS AIM gives you the ability to create named expressions and property values, which you can then reuse elsewhere in your study to build complex relationships and intermediate values. In this demonstration, you'll learn first how to create named expressions and named values, and then how to use them to define other expressions. Here, I have a static structural model with the force applied on the y-axis. I'll start by using named expressions to modify the direction of the force, so it's on the xy plane. For y, I'll create a named expression, force mag. The newly created named expression is shown under Related Objects. All named expressions and named values being used in the current context will be shown here. By clicking this link, I can navigate to the named expression. The expression can be edited here, but I'll leave it for now. From here, I'll use the Add icon to create another named expression. I'll name it Force Angle and set it to 45 degrees. Back in the named expression table, I can see that force angle has been added. If I open the force magnitude object, down here, I can see that Related Objects shows the reverse relationship, the boundary condition force 1, which uses the expression. Now, I'll return to force 1. I'll use the named expressions I've already created to define two new expressions for the x and y force 1 components. First, I'll define x as force magnitude times the cosine of force angle. Next, I'll define y as force magnitude times the sine of force angle. Now, I want to name the expressions I just created, so I can track the x and y components. For x, I'll use the menu to create a named expression, fx. For y, I'll create a new named expression, fy. If I go to the named expression table, I can see that the named expressions fx and fy are in use. So, now my two original named expressions, force mag and force angle, have been used to construct two new named expressions, fx and fy. Now, I want to edit one of my other named expressions. Down here, I can see that fx uses two other named expressions. And here are the two named expressions used to define fx. I want to change the value of the force angle named expression from 45 degrees to 70 degrees. Because the named expression is an independent object, I can change the expression here. Note that the evaluated value is updated accordingly. Now, if I return to study and open the named expression table, I can see all four of my named expressions. All named expressions defined in the study will be shown here. Next, I'd like to calculate the total mass using another set of expressions. I'll go to the material, structural steel. I'll need the density to calculate the total mass, so for the density property, I'll create a named expression, my density. Now, I'll update physics. Now, I'll go to Results. Here, I have a calculated value called the calculated sum of element volume. I want to multiply the density of structural steel by the volume. So I'll create a named value for the volume property, calling it my volume. This way, I can easily reuse the value. I can see this value is still undefined. I want to use it to define another calculated value, so I'll go ahead and evaluate this one now. Now, I'll create another calculated value to calculate the mass. I'll name it Calculated Mass, and we'll set method to user-defined expression. I'll set expression to my density times my volume. And then I'll name this expression total mass. Now I'll update results. To review all my named expressions and named values, including my total mass result, I can go back to the study pane and look at the named expressions and values table. This table shows a complete listing of all the named expressions and named values for the study. Here, I can verify that the total mass has been evaluated, providing the total mass calculated for all the elements. This concludes this demonstration of named expressions and named values in ANSYS AIM.